This question is on energy, and you're given a golf ball that's traveling horizontal in the direction shown, which is to the right. That means to say you push the ball from rest up this small hill, then after that this portion here will be flat again. And assuming no kinetic energy is transferred to thermal energy or sound, so assuming ideal situation, no friction, no air resistance, and the gravitational field strength is 10 Newton per kg. So they ask for what's the minimum speed of the golf ball that's needed for the ball to reach Y. To solve this question, definitely we'll be using conservation of energy, and you should know that the total energy at any point will be the same. In other words, the total energy at point X is equals to total energy at point Y. That's true. But the thing is, that will be a mistake if you consider X and Y, these 2 points, because I know the height of Y, which is I will know the GPE of the ball, but there's no way I know the KE here. Okay, so the point that you should focus on is actually this point over here. Let's call it the Z here. Alright, so instead of taking X and Y, you should be focusing on these two. Why? Because they ask for the minimum speed. That means to say, as long as the ball just barely able to clear the highest point of the hill Z there, you will be able to go beyond this point, and then you will definitely reach Y. Okay, so let's focus on these two. So I can equate total energy at point X is equals total energy at point Z. And I'm going to treat this dotted line here as my reference ground. So since the golf ball at X there's no height, so there's no GPE, so it's purely just kinetic energy. All right, and for point Z here, as I mentioned, you treat it as where the ball just barely can clear the thing. So I can treat it as there's no KE at point Z, there's only GPE. So as long as I can find the speed, any speed higher than that, it will be able to clear the highest point at Z and then reaches Y. So let's put the formula in. Half mv squared is equals to mgh. And you can see that why I always prefer you to do this working, because just like this question, the mass of the golf ball is not given to you, but you can still solve. Why? Because mass is the common term. So you are left with half v squared is equals to your g, which is your 10 times the height, which is 40 cm. But another thing to take note is you have to change it to meter all in SI unit, so that will be 0.4. So just simple math, you go and calculate your V, remember to square root the thing, and that will be 2.8 meter per second. Alright, so D will be the answer. Now let's consider another scenario where the golf ball is at X, but this is at a higher ground, and there's a hill here, and then after that there's a lower flat portion here. That's where the ball reaches at Y. It's similar, but the setting is a bit different. How do you solve this? Now, once again, it's the same thing. You have to understand that as long as the ball can clear this highest point of the hill, it will be able to reach Y. So I should be more concerned with your X here and your Z here, which is the highest point. So it's the same thing. Total energy at point X is equals to total energy at point Z here. But from here, even though the lowest point, the height 0 is over here, you do not need to treat that as the reference height. I can make it easier by treating the reference height over here. Alright, let's draw it here. If I treat that as my lowest height, it will be actually easier. So at point X, same thing. Since that's my reference height, there's no GPE, there's only KE of the golf ball at X. And at Z here, the height that it needs to clear is only 10 cm. So that will be your GPE. And let's open up. Half mv squared is equals to mgh. Alright, and mass can be cancelled off once again. So you're left with half v squared is equals to 10 times, and the height is only 10 cm, so 0.1 meters. So we can solve that will be 1.4 meter per second. All right. Of course, it's not wrong to actually, if you want to use this as a reference ground, can. Then the initial energy at point X will have a GPE, which is of 30 cm, plus the initial KE. And then the energy at point Z will have to be the gravitational potential energy, but the height will be 40 cm. You can do that also. So I hope if you come across this kind of question, you should know that you should focus on the highest point here. All right, and hopefully you can solve the question. Thank you.